Okay, in this section, we're going to talk about lines. Most of this should be reviewed for you guys, but it'll be a good refresher to go through the videos. So when you come to class, you'll be prepared to start your work. Okay, let's start with the x and y intercept of a line. So the x-intercept of a line, and we'll talk a little bit more about this in class, but it's the point at which the line crosses the x-axis. And then similarly, the y-intercept is the point at which the line crosses the y-axis. Okay, now I'm just telling you guys a brief overview. In class, we're going to talk about more about what this means. But for now, let's just go through how to find the x and y intercept. So it says, to find the x-intercept, you set the y equal to 0 and solve for y. Okay, so when we're looking for the x-intercept, we're going to set the y value equal to 0 and solve for x. Okay, so let's do that. We have negative 3x plus 5 times 0, and that's going to equal to 15. So 5 times 0 is 0, so we get negative 3x equals 15. You divide both sides by negative 3, and you're going to get x equals to negative 5. If you leave your answer like this is incorrect. It's actually incomplete, because any point is an x-coordinate and a y-coordinate. So the x-coordinate is negative 5, but to get that, we set the y-coordinate equal to 0. So the point is going to be negative 5, comma 0. So you have to write the x-coordinate, x-intercept, as a point. Now to find the y-intercept, we do the exact opposite. To find the y-intercept, we set the x equal to 0, and we solve for y. So in our equation, instead of negative 3x, we're going to replace the x with a 0. Then we got plus 5y equals 15. Negative 3 times 0 is going to be 0. That crosses out. So we get 5y equals 15. You divide both sides by 5, and you're going to get y equals to 3. Again, if you leave your answer like this, it is incomplete. You have to write this as a point. So the y value is 3. The way we got that was we set the x value equal to 0. So your y-intercept is going to be 0, 3. So this is your x-intercept, and this is your y-intercept. Okay, now we have to graph this. Okay, so here's what the graph looks like. The point negative 5, 0, it's going to be 1, 2, 3, 4, 5. It's going to be here. The point 0, 3 is going to be here. So you plot the x-intercept, you plot the y-intercept, you connect them, and there's your line. So this is one way to graph the line, using the x-intercept and using the y-intercept. I'm going to leave this up here, I'm going to refer back to it, and I'm going to show you guys why you set the y equal to 0 and set the x equal to 0 in order to get the intercepts after the next example. Okay, so your next example, it says find the x-intercept and y-intercept of y equals to 3x minus 6. Okay, so we're finding the x-intercept and y-intercept of y equals to 3x minus 6. Let me get rid of the old work. Okay, so what are your steps? When you're looking for the x-intercept, you set the y value equal to 0 and solve for x. Okay, so in your equation, y equals to 3x minus 6, I'm going to set the y value equal to 0. So we're going to get 0 equals to 3x minus 6. I can't just divide by 3 because this is an equation, and I have to get the 3x by itself. So I'm going to first add 6 to each side. So this gives me 6 equals to 3x. I divide both sides by 3, and I get x equals 2. Okay, now, that's not a complete answer. What is a complete answer? The complete answer, you have x equals 2 and y equals to 0. So my x-intercept is going to be the point 2, 0. Y-intercept, we set the x value equal to 0, so we're going to get y equals to 3 times x, which is 0 minus 6. So 3 times 0 is going to be 0, and 0 minus 6 will give you negative 6. So the y-intercept is negative 6. Incomplete answer. The complete answer is going to be the point 0 comma negative 6. Okay, that's my x-intercept. That's my y-intercept. So let's graph that. My x-intercept is 2, 0, which is over here. My y-intercept is 0, negative 6, so it's here. And if I connect the 2 points, then the line is going to look like this. Here's what I want you to notice. This x-intercept for the first line was negative 5, 0. This x-intercept was 2, 0. No matter how many lines I draw, let's say I draw another line that looks like this. This will be my x-intercept. So my x-intercept, if I just draw a random line, this will be the point negative 1, 0. Notice what happens. All the y values are going to be 0. On the x-axis, the y value is always going to be 0. This is like y equals 1, y equals 2. So if the y value was 1, you would be up there somewhere. If the y value was 2, you'd be up there somewhere. The only way you end up on the x-axis, because that's where by definition, that's where the x-intercept is, the only way to get on the x-axis is to set the y equal to 0. Which is why we set y equal to 0 and solve for x. Same thing for the y-intercept. The y-intercept is on the y-axis. For example, for the first line, our y-intercept was 0, 3. For the second line, our y-intercept was 0, negative 6. Notice that all the x values are always going to be 0 on the y-axis. The line that I kind of made up, this line right here, the y-intercept there, that's 0, negative 3. Again, the x value is going to be 0. So anytime you're looking for the y-intercept, you're on the y-axis, and on the y-axis, the x values are always equal to 0. That's why this method works. Okay, so x-intercept, y equal to 0, solve for x. Y-intercept, set x equal to 0 and solve for y. Now we're going to go to the next topic, which is going to be slope of a line. Alright, so the slope of the line is the slope of a line is the rise over the run between 2 points. Okay, so the slope of the line is the rise over the run between any 2 points on the line, as it says in your media notes. So between any 2 points on the line. Okay, so the first problem says plot the points negative 2, 4. The first example rather says plot the points negative 2, 4 and 1, negative 2. And find the slope between those 2 points. So let's go ahead and do that. You guys have a graph, but I'm going to draw a graph and I want you guys to plot these points on your graph. Okay, so our points are negative 2, comma, positive 4. So that's my first point. And my second point is 1, comma, negative 2. And I have a line that goes through these 2 points. So let's look at the definition of a slope. The slope of a line is the rise over the run. The rise, so let's start with this point. Let's start with the lower point. The rise is how many units am I going up? So I'm going up 1, 2, 3, 4, 5, and 6. I'm going up 6. So my rise is going to be 6. The run is how many units am I going across? So I'm going across 1, 2, and 3 units. Okay, but because I'm going in the negative direction, my run is going to be negative 3. So in this case, between these 2 points, my slope is the rise over the run. The rise is 6 units. The run is negative 3 units. And if I divide that, it gives me negative 2. Okay, so what does that mean? What does negative 2 mean? Negative 2 means that on that line, every time you go down 2 and across 1, you will find another point on the line. Okay, so let's say I start up here. Okay, I'm starting up there. My slope is negative 2 over 1. That means if I go down 2 units and I go across 1 unit, I find a point on the line. Again, if I do the same thing, I go down 2 units and go across 1 unit, I find a point on the line. I go down 2 units, go across 1 unit, I find a point on the line. So that's what the slope tells us, negative 2 over 1. The rise is negative 2, the run is positive 1. Now you can also do it this way. You can also rewrite that as 2 over negative 1. Okay, how does that work? 2 over negative 1 means if you're starting from a point and you go up 2 units and you go left 1 unit, you go up 2 units and you go left 1, you get a point on the line. You go up 2 units, go left 1, you get a point on the line. You go up 2 units, left 1, you get a point on the line. So going down 2 and across 1 is the same thing as going up 2 and left 1. Negative 2 over 1 and 2 over negative 1 are the exact same thing. So the slope is the rise, or the change in y's, over the run, which is the change in x's. Alright, the next example asks you to do the same exact thing, but using 2 different points. Okay, so our next set of points are 5, comma 2, and negative 3, negative 1. So the directions say plot the points and find the slope between those 2 points. Okay, so 5, 2, we're going to have 1, 2, 3, 4, 5, comma 2. Negative 3, negative 1, we have negative 3, comma negative 1. These are my 2 points. And there's my line. Okay, let me label these points. So this point is 5, comma 2, and this point is negative 3, negative 1. How do I find the slope? Slope is a rise over the run. So I'm going to start with the lower point, start here. How much am I going up? So I'm going up 1, 2, and 3 units. So my rise is 3. How much am I going across? I'm going across 1, 2, 3, 4, 5, 6, 7, 8 units. I'm going across 8. So my slope is going to be 3 over 8. This time it's positive. This tells me that from any point, if I go up 3 and I go across 8 units, I will find another point on the line. Okay? It also goes the other way. Remember that a positive over positive is a positive, but a negative over negative is also a positive. So how does that work? If I take a point on the line, and I go down 3 units, 1, 2, 3, and I go 1, 2, 3, 4, 5, 6, 7, 8 units to the left, that'll also give me another point on the line. So going up 3 and over 8 is the same exact thing as going down 3 and left 8. Both of those will give you a point on the line. Okay? Now, every time we don't want to be plotting points and counting. Okay, that doesn't make sense. So there's a better way of doing this. The rise, there's another way to find the rise without counting. The way you find the difference between any 2 points is by subtracting them. So in this case, my rise was 3. If I subtract my y value of 2 minus my other y value of negative 1, 2 minus negative 1, guess what? That gives me positive 3. So the rise can be found by y2 minus y1. Same thing for the run. I'm starting at negative 3 and I'm ending up at positive 5. How much am I going across? I'm going across 8 units. How do I get that? I take my second x value minus my first x value, 5 minus negative 3, it'll give me a positive 8. So instead of counting, you can just subtract the y values, subtract the x values to get the difference between them. So the run you can write that as x2 minus x1. Okay, so since slope is just rise over run, and we can find the rise by doing y2 minus y1, find the run by doing x2 minus x1, the slope of any line can be given by the formula y2 minus y1 over x2 minus x1. Okay, so the slope of the line is given by that formula. Okay, and another way to think about slope, y2 minus y1, this is the change in y values, divided by x2 minus x1, which is the change in x values. That's another way to think about slope. Okay? All right, so what do we do with this? Let's think about a real-life application. We'll leave this formula. Okay, in your media notes, here's what the problem says. It says, Jim works on the assembly line for an auto parts remanufacturing company. By 9 a.m., his team has assembled 29 carburetors. Okay, so let me write that down. By 9 a.m., at 9 a.m., this is the time, and this is the number of carburetors. At 9 a.m., Jim's team has assembled 29 carburetors. Okay, now by 12 p.m., so 3 hours later, by 12 p.m., they have assembled 87 carburetors. Assuming the relationship is linear, which means that they keep growing at a steady pace, find the slope of the line and interpret the results. So what I want to do is, I'm going to take this first set of numbers and make it into a point. So at 9 a.m., 29 carburetors were assembled. By 12 p.m., 87 carburetors were assembled. Okay? If you want to look at this kind of visually, I'm just going to do a very rough sketch. By 9 a.m., we had 29 carburetors. So this is 9 a.m., that's 29 carburetors. By 9 a.m., we had 29 carburetors. By 12 p.m., so 3 hours later, we had 87 carburetors, which is going to be like up there somewhere. And again, it's a very rough sketch. So this is 12 p.m., that's 87 carburetors. So by 12 p.m., 87 carburetors were assembled. Now we're going to find the slope of this. Okay, so the slope, we got the formula right here. It's y2 minus y1. So 87 minus 29 divided by x2 minus x1, which is 12 minus 9. Okay, so let's subtract this. 87 minus 29 will give you 58, and 12 minus 9 will give you 3. Okay, so let's think about this. What is this telling us? This is telling us that the change in y values, remember the y values represent the number of carburetors, over the change in x values, which represents the time, is 58 over 3. So this means that every 3 hours, 58 carburetors are assembled. Okay, this little symbol means change. This represents the change in carburetors. This represents the change in time. So every 3 hours, 58 carburetors are assembled. Okay, that means by 3 p.m., so I'm going to write another point over here, we know that every 3 hours, 58 carburetors are assembled. By 3 p.m., 58 more carburetors are going to be assembled. So 7 plus 8, that's 15. 9 plus 5 is 14. So at 3 p.m., 145 carburetors are assembled. That's what the slope represents. The change in time compared to the change in carburetors.